Hello everyone, and welcome back to SHENZHEN I. So, you guys remember back in, school or whatever, where there were tests that was like, hey, read all the instructions on the test before continuing. I had an experience last night that reminded me of this. So, let's read this new product email, and then I'll continue this story. Spoiler blocking headphones. Like many people in the office, I am a huge fan of the miniseries Get the Throne. The heroics, villainy, and sudden plot twist reversals have my wife Xiaomei and I waiting with bated breath for each new episode. By the way, it looks like they got married. Unfortunately, we missed last night's, and this morning I overheard people in the office discussing the latest twist before I could say anything. Surely there is some way to prevent being spoiled like this, perhaps with headphones that replace discussions of certain television shows with scrambled audio. Sorry about that. Yeah, here's a list of words, and he made a suggested list of words for us. Great. So we'll make some headphones, and I hope that maybe looking at this will be a good a good backdrop for explaining what I mean about reading the instructions clearly before proceeding. So this is, I think, the first episode of SHENZHEN I that I have recorded but not uploaded. Not this one. Obviously I've uploaded it. You're watching it, right? But the previous episode, I made this gigantic mess here. Why did I do that? So I went and I read the spoiler list, and I was like, oh, okay. There's like 4 lists of 6 words each, and they're each like 2 letters long, or not 2 letters, but 2 numbers long. Okay, so we gotta somehow build a thing that checks against 24 different words. And, like, I mean, if you look at it, that's pretty hard, right? You can only fit, like, 1 word list in a single ROM. And we have 4 of them, like, we need 4 ROMs, and, like, you need at least, like, 4 XBus inputs to, like, it's, like, a mess, right? So, the reason that I'm an idiot... So anyway, I spent like half an hour at least just like trying to imagine some way I could implement this, and like I just put stuff down, and like I never wrote a single line of code. The wiring was just impossible. And so I decided like there's clearly some assumption I'm making that's wrong, and I couldn't figure out what it was, so I just put the puzzle aside for a while and to come back the next day. And well, looking at it again, it's in fact pretty clear. We're actually only supposed to use the Get the Throne list of spoilers. The other 3 lists are just completely irrelevant. Right? Rude. So that's just 1 ROM module. That's no problem at all. And it simplifies, like, in addition to just, like, the wiring is less complicated than in my Bizarro Land thing that I built here, thinking I had to support 24 words. It also simplifies the algorithm a little bit. We'll see in a moment, I think, when we look over the specs, what it was that was giving me trouble. Anyway, so let's look at the specs down here real quick. Audio, that's this one, is a simple input connected to a microphone. Audio out is a simple output connected to headphones. Keywords, those are coming in through here, is a non-blocking XBus input connected to a natural language processing device that detects spoken words. Override is a simple input connected to a button. So the idea is that we're going to be getting, at all times, we'll be getting sound in through here. And we'll sometimes get words in through here. And when we do get words in, we need to check them against the spoiler list. And if they match anything in the spoiler list, we need to like flip a bit that says we're outputting audio of 50 instead of passing through the actual audio indefinitely until we receive a button press here that says to go back to normal pass-through mode. So I actually ended up like looking around on Reddit to see like what the heck, how is this puzzle possible, because I thought I had to do all 4, right? And so I'm a little bit spoiled on approaches to this puzzle, but the obvious algorithm, which is of course the one that like you would think of immediately, is like, let's just write down all the numbers in pairs in a single ROM, and we'll have something like this, I guess, and we're probably going to need some kind of one of these guys, right? Because we don't have enough ports, enough simple I/O ports. But anyway, like this guy's going to be listening to these. When it gets a word, go look it up in the ROM, toggle a flag somewhere, you know. That's the obvious algorithm. Something that I saw being done as well on Reddit is, rather than writing down all 12 numbers, you could try writing down just 6, the deltas between A and B, each pair. They happen to be unique, right? And as it happens, the test data never pass you any other words that have the same delta, and so you'll pass the test if you kind of skimp in that way. That's the way we could simplify things, but I would rather implement it correctly, so I don't think I'm going to do it that way. I guess it is possible to do this all in one chip, or one microcontroller. I definitely did see that being done, although I suspect it was by the guy who, well, there's one guy who posted it and said he had used the solution, the trick to optimize by only looking at the delta. But then there were some comments later saying, actually, if you work really, really hard, you can squeeze a non-cheating solution into 14 lines. Which sort of, you know, sounds cool, but I suspect that I am not going to be putting in that much effort. So we need actual direct simple I/O connections to here and to here. We can't use an I/O expander for that because we need to be able to read and write values other than 100 on those 0 and 100 on those channels. So the only thing we could do is get out of here. Use this expander to do like, oh, you know what? I never noticed. So like I remarked a while ago that I realized at some point that, oh, this one gets rotated to be up here rather than being mirrored to be over here. And I just assumed there was no way you could tell that without testing. But actually the labels, right? This is P0. This is P0. So the manual is quite clear about that. But I mistranslated the manual in my brain by saying, oh, the lowest one is the ones bit, not the one labeled P0 is the ones bit. Oh well. So like this is, no, flip please. This is sort of the approach that you would take if you wanted to do it all on one chip, basically, right? Is connect this guy up to here. Where's my ROM? Here. This is sort of like, you definitely need all of these wires, right? And these wires are necessary and sufficient. It's just a question of fitting all the code in here. I guess we could try doing it all in try doing it non-cheating in this and see. It's going to be a little bit irritating to rewire. otherwise. I'm not sure exactly what the right way to do it would be, really. I guess basically we would create one module like this or something, whose job is to read from this and do the forwarding, and we would just connect to him over XBus and say, oh, switch into blocking mode or switch out of blocking mode or whatever. Then he would have both of our he would have both of our simple I/O ports if we did that. That wouldn't be very useful, would it? Because we would need to talk to him over XBus, and he wouldn't be freeing up an XBus port if we did that. So this guy would have no ports to talk to him on if we did it that way. I guess we could free up this port by throwing this chip out and actually talking simple I/O, since this perspective chip would be freeing up the two simple I/O ports. So that's the thing we could do. But okay, let's try writing the obvious code in here, and I'm pretty sure it's going to take longer than 14 lines, but we'll see how it goes. So where are we going to store the stuff that we need? I'm not sure what we need in ACK. Like, it seems like in DAT we want to store the bit saying whether we're in in spoiler blocking mode. And in ACK, like, do we need anything? Doesn't seem like it. So let's go ahead and test equal x1 100. If so, move 0 into DAT. Now, 0 I'm intending to mean we're not blocking sounds. And I'm sort of conscious of the fact that this is a kind of an enum thing that I'm always doing when I don't need to. So if there's some way to use a value other than 0 that I can actually reuse, that would be nice. I don't really see it though. Okay, so fine. Otherwise, we won't touch the mode here. And now we're going to... I guess we need to store in ACK the first word of the pair, right? So that we can compare it multiple times. Move x0 into ACK. And now we need to test whether that's the same as the word we're pointing at here. So test equal ACK and x2. If they're the same, then what? We need to test equal x0 and x2. Actually, let's be careful here. No, hang on. Shoot, it's a little tricky to organize all these cases. Because if they're different, we need to skip over a word, right? Test equal ACK x2. So if ACK, which is our incoming word, is not equal to x2, which is our spoiler word, we want to throw away a byte from here before we start doing other tests. So let's move x2 to null. Okay. Now, if it was the same, then instead of throwing x2 away, we compare it to x0. And if that's also true, we need to move 1 into dat. We found our thing. Great. Now let's test equal. Our address register here is x3 for, did the music just stop? Alright, it's back. That was weird. Test equal x3, I guess it'll be 12 when we've read 12 things. So if it's not equal to 12, then jump to up here somewhere. This, I guess, is our scanning loop. Jump to scan. Scana. Okay, and then we fall through, and what we do is we test whether dat is 1, in which case we move 50 to P1, otherwise we move P0 to P1. We sleep 1? I must be missing something here. Right? Because this, I don't know, I kind of felt like it was going to be hard to squeeze it all in here, but this feels about right. So there's one little niggling little detail, which it turns out is going to be okay, which is we never actually get one word right after another. You'll notice that there's a case that we sort of didn't handle properly, which is if we read in the first word, notice we never actually read in the second word. We're leaving it in the XBus buffer until we find a matching first word. And then when we do, we read the second word and see if it's the same. So, notably, something I did notice without having to read any Reddit spoilers, thank you very much, is that no two spoilers here have the same first number. So what we can do is when we find a matching first number, we can read and throw away the second number from the input, because we'll only ever need it once. But what if we don't ever find a match? We'll never read the second number out of the XBus, right? It'll just be stuck there in the buffer. But this turns out to be okay, because it just means in the next time cycle, we will have a single number on here, and we'll read it in, and like maybe it matches one of the first number pairs. But when we go to read the second half of this imagined word we have, it'll just be -999, and it won't match anything, and that'll be okay. So I'm not sure exactly what line I'm missing in here. There's probably something. And certainly we could be more power efficient if we could find a way, like maybe here, to move out to move the second word to null, basically. I just realized what we're missing. That's the one line we still need, which is to reinitialize this to point to the beginning of its stuff. So let's start with that. Oh no! I need to do, well, I was thinking, oh, I need to sleep for this thing. I don't need to, no, I don't. Since what we're really having trouble with is cramming enough lines of code into this, I think it's kind of okay that we never even check whether ACK is -999. We just go ahead and look up -999 in here. and like, oh well, who cares? Yeah, that seems alright. It's gonna waste a lot of power, but it's gonna like hopefully let us fit everything on this chip. We just need to do the one more thing, which is to move a 0 to x3 at some point in this loop. And since we're executing all this code every cycle, it doesn't really matter where we do it. So just move a 0 to x3. And let's copy in some numbers, right? 711, 573. 711, 573. Next one is 495, 160. I hope you guys love listening to me sort of sing-song numbers so I can remember them for half a second. 575, 645. Here, 712, 917. These ROMs are like not that fun. 356, 361. Thought I had typoed there. 138, 420. Okay. Now we could also probably check for whether the value here is 0 instead of just checking whether the address register is what we need it to be, but I don't see any compelling reason to prefer one over the other. I don't know. Let's kick the tires, see how it goes. So we tested x1. What is x1? This. All right, let's start over. I missed the test of that. Test x1. Yeah, and so that comes in through this. Was it 100? No. Therefore, we move 0 to x3, initializing this to point to the beginning. Move x0 into ACK. I presume that's this? Yes. Now we're going to scan all of this, looking for -999, throwing away the second value because we're not going to find any matches. We get to the end. Is x3 12? My goodness, yes it is. So we check what dat is. Is it 1? No. Therefore we copy this 67 to the output. So on cycles where we don't receive any input at all, we're fine. On cycles where we get an input, 356 and something, so we go through, we look for 356s. Uh-oh, did they find one? Not sure. Test equal x0 to x2. Ah, so there is a 356, but the second half of the word doesn't match up. And so we did not choose to move 1 to dat. Perfect. Okay. So we got to test that case. And we didn't activate the blockers. Great. Here, 575. Are there any 575s in our list? Yes, this one. And 645? Is that right? Shouldn't this be turning the... Oh yeah, we're switching into, hopefully now, switching into blocking mode next. Let's just skip a bit. Here we go. Is ACK equal to x2? Yeah, it actually is. Is x0 equal to x2? Yeah, that's true too. So we're gonna put 1 in dat, saying we're blocking, and continue scanning because it doesn't really hurt us to do so. Now we say is dat 1? Why, actually it is, so we just write 50 instead of the actual sound. So that's correct and intended. And this all, like, 495? Yeah, we have a 495 in the list. Do you have a 57? We do. I wish they would give us a test case where, like, the first number pair isn't there. 565? The next one is an example of that, right? Yeah, 565 is not in our list at all. So this should be our first example of the case where we just leave something on the X bus. Right, we're gonna like That 160 is just going to sit there while we scan through everything. We never end up reading it. We don't have a bite to throw it away. And so in the next phase, we read this 160 thinking it's the beginning of a word. Oh my. Well, actually, first we put a 0 in that because the button was pressed. But now we read this 160 and we think it's the beginning of a word, but it never actually matches with anything, so it's fine. And even if it did, the -9 and 9 would not match with the second half. So actually, I think we're doing fine now. Yeah. Alright. I thought this was going to be harder to code up than it was. The obvious approach just works. As long as you're... Wow, that seems like a lot of test cases. As long as you don't try to do things that aren't necessary by like being extra clean with how you handle your XBus. If we ever got 2 different inputs in back-to-back time segments, this would fail. So that's the way that we cheated a little bit. But good production costs. Nobody did it cheaper than this. Power usage a bit high. Lines of code. Nobody did it cheaper than this, it looks like. So great. I have made many fans of popular shows like Get the Throne happy to know they are not in danger of spoilers as they walk into the office in the morning. Certainly my wife, Shama, and I are very much looking forward to last night's episode, knowing that we will be genuinely shocked by the events to come. That's pretty funny that he's giving him the spoiler anyway. We need more than just headphones. And we have another thing here. I noticed this one show up a long time ago, and I never read it. I want to know what the deal is with Cool Dad. Wait, the Cool Dad vape pen thing, remember? Yeah, so what was that all about? He got arrested before he could start the tour with all these vape pens. They got a call. They want the inventory. Okay. Hang on, are we sure this all wasn't just some elaborate publicity stunt? Concert's off, no wait, it's on again. There's a rumor online that Cool Dad was actually framed by his twin rivals, DJ Like and DJ Subscribe. That's right, guys. Never before on this channel, I reminded you, please like and subscribe. I don't know, do whatever you want, I don't care. It'd be nice if you subscribed, I would hit 100. I'm at 99 at the time of this recording. Get that 3-digit rollover. Anyway, will we get any sort of special deal on tickets? Xiaomei and I would be interested in going. Okay, great. Well, there seem to be just these last 3 puzzles left. We haven't gotten any updates, any new puzzles for a little while. Maybe there'll be another when we unlock all these. Who knows? We're getting close to the end of the game. I'm excited. I hope you guys have enjoyed this episode. Thanks for watching, and I'll see you next time.